The first step is to declare the constants and variables that will be used in the program by giving them a determined value.
We use these values because they are able to perform a PMW type of signal that resembles an analog signal.
In the void setup, we use the command pinmode to determine if the previously declared constants will be an output or an input. In this case, they are outputs, because they will send signals to the LEDs.
The void loop is used to declare the actions that will be performed in a loop as long as the Aruino is still connected to a computer.
First, we use the command for in order to state the amount of times that the actions in the keys will be repeated, instead of writing the instructions for the action 4 times.
Between the keys, we use the digital write command to determine if whether the state of the signal of the LED would be high or low. First, we stated that the first and third LED would be in a high state, meaning that those LEDs would be on. In the second part, we stated that only the second and fourth LED would be high, so that only those LEDs are on. Finally, after the keys, we stated that all the signals would have a low state, meaning that all the LEDs would be off.
We also added a delay of 3 seconds. After the delay, we use the for command again to make the LEDs turn on progressively. This by determining that it should start with a value of 0, meaning it is off, and that it has to reach a value of 256 so that it is completely on.
Then we use 2 plus signs to determine that it should increase the value. Then we use the for command again to make the LEDs turn off progressively. This by determining that the starting value should be of 255, meaning it should be completely on, and to decrease its value to 0 so that it would be off. To do this, we used 2 minus signs to determine it should decrease.
Finally, we repeated this process for all the other LEDs.